Hi, Professor Baldwin here, and today we're going to learn about complex numbers. Remember that complex numbers are numbers in the form a plus bi, where a is the real number part and bi is the imaginary part. Remember that this letter I, the lowercase I, represents the imaginary unit, and it's equal to the square root of -1, or if you square I, you get -1. The most important reason to have this imaginary unit is to be able to take the square root of a negative number. So if we take the square root of some number a, which is negative, we'll get I times the square root of a. Let's look at a couple of examples. Example 1, we're taking the square root of -3. Well, this negative comes out of the square root as I, and that would leave us with the square root of 3. 3 isn't a perfect square, so this is the simplified answer, I square root of 3. How about example 2? The negative again comes out as the imaginary number I, and we get I times the square root of 98. Well, 98 factors to 49 and 2. So we have two separate square roots, one with a radicand of 49 and one with a radicand of 2. 49 is a perfect square. Square root of 49 is 7. So that comes out of the square root of 7. We have our I, and we're left with the square root of 2. So the simplified form of square root of -98 is 7i square root of 2. Now, what if we need to add, subtract, or multiply complex numbers? Well, adding and subtracting, you're going to add the real parts together and then add or subtract the imaginary parts, based on like terms. And when we multiply, we'll just use FOIL and remember to use that property that I squared is also equal to -1. That helps us simplify a little bit further. Example 1, we're adding these two binomials together. So we have 3 plus the square root of -16 plus 2 plus the square root of -25. I just removed the parentheses. Since there's no negative or anything outside the parentheses to distribute, it stays like this. Now I'm going to simplify these radicals. So 3 stays the same. The square root of -16. Well, 16 is a perfect square, so that would be 4. And taking the square root of the negative gives us an I. And the 2 stays the same. Square root of -25. 25 is a perfect square. The square root of that is 5. And the square root of the negative part is I. Now, if we rewrite the terms so that we have like terms near each other, we have 3 plus 2 plus 4i plus 5i. Now we just combine the like terms. 3 plus 2 is 5, and 4i plus 5i is 9i. So we've simplified this and written it in a plus bi format. Let's try number 2. Here we have subtraction, and we need to distribute that negative sign through the parentheses. So we'll have -5 plus 2i minus a -4, which is plus 4, minus a -3i is plus 3i. Again, let's reorganize it so that we have the like terms near each other. Now when we combine our like terms, -5 plus 4 is -1, and 2i plus 3i is 5i. Now example 3, we need to use FOIL because we're multiplying two binomials together. So our first term, 2 times 2, or 4. Our outer, 2 times 5i, which is 10i. Our inner, 3i times 2, which is a positive 6i. And then our last, 3i times 5i, which is a positive 15 I squared. Now, I like to combine my like terms first. 4 is my only constant at this moment. Then I have 10i plus 6i, which is 16i, plus 15i squared. But recall, we can rewrite the I squared. So we have 4 plus 16i for our first two terms. Then we have plus 15. And I squared, if you remember, is the same as -1. So now if we multiply the 15 times -1, we have 4 plus 16i minus 15. And that simplifies to -11 plus 16i. Now look at example 4. We can start with FOIL, or we can try to simplify these radicals that we have. I suggest simplifying the radicals, especially since 16 and 25 are perfect squares. So the first binomial becomes 3 plus 4i. The square root of the negative gave us the I, and the square root of the 16 gave us 4. And the second binomial is 2 plus 5i. Now when we use FOIL, we'll get 6 plus 15i plus 8i plus 20i squared. And let's simplify. Combining like terms, we have 6. 15i plus 8i is a plus 23i. And then we have plus 20. I squared is the -1. Okay, let's continue to simplify. We have 6 plus 23i minus 20. Now we're going to combine the 6 and the -20, and that gives us -14 plus 23i. Now we've covered addition, subtraction, and multiplication of complex numbers. So on page 2, let's look at how to divide complex numbers. Okay, so if we have a complex number, something that's a plus bi, in the denominator of our fraction, we're going to need to use what's called the complex conjugate. And we're going to use this complex conjugate of the denominator and multiply the numerator and the denominator by it. So the conjugate of a complex number, a plus bi, is just a minus bi. So you take the same terms and you just change the operator in between them. Sounds confusing, but I promise you it's not that difficult. So look at example 1. Our denominator is 5 minus 11i. What we want to do is multiply by 1. So we're going to put the conjugate in the denominator and in the numerator. So we rewrite the denominator, just the terms, and we change the operator. Right here it's subtraction, so our conjugate is going to be addition. And because our numerator and our denominator here are the same, this is in essence the same as multiplying by 1. Now, why do we use the opposite? That's because a plus bi times a minus bi is the same as a difference of squares. So when you FOIL this, the outer and the inner terms are going to cancel each other out. So the result is going to be a squared, so the first two terms, and the last two terms, so minus b squared I squared. And remember, our goal is to get rid of I. And sure, we have I squared, but we know how to rewrite that as -1. Okay, maybe I just made that sound a little more confusing, so let's finish this problem. We have the conjugate, so now we're just going to multiply. Our numerator is going to be 3 times 5 plus 11i, and our denominator, for this one I'll write it fully out, it's 5 minus 11i times 5 plus 11i. Now, right below it, I'm going to FOIL. So first is 25. The outer term is a positive 55i. And the inner term, because these are difference of squares, is negative 55i. And last is negative 121i squared. Now notice these middle terms that we got from the outer and the inner cancel each other out. They're opposites. So this simplifies to 3 times 5 plus 11i over 25 minus 121i squared. Simplify the numerator. We need to distribute that 3, so we get 15 plus 11i over 25 minus 121 times negative 1, right? Because I squared is negative 1. Keep simplifying. We get 15 plus 11i over 25 plus 121. A couple more steps. Our numerator stays 15 plus 11i, and our denominator is 146. Still not done, because we need the format a plus bi. So we need to break that numerator up and have 2 separate fractions. So we have our real number, 15 over 146, plus our imaginary component, 11 over 146i. Let's look at another example. Here our denominator is 2 plus 3i. So our conjugate is going to be 2 minus 3i. Multiply the numerator, and you have 5 times 2 minus 3i. Our denominator is 2 plus 3i times 2 minus 3i. We're going to distribute in the numerator to get 10 minus 15i. And in the denominator, we just need the first terms and the last terms. The first terms give us 4, and the last terms give us minus 9i squared. Simplifying that I squared, our numerator stays the same. Our denominator is 4 plus 9, because the I squared is negative 1. So you can kind of just get rid of the I squared and change the sign of the real number component. Keep simplifying. We have 10 minus 15i with a denominator of 13. And remember, we need this as a real and an imaginary component. So the denominator stays the same of 13, and the numerators are 10 and 15. Okay, let's look at one more example. This one is a little more challenging, and that's because our denominator here, 1 minus I squared. First, we want to simplify that 1 minus I squared. So our numerator stays the same. And our denominator, what that means is 1 minus I times 1 minus I. So keep our numerator again. Let's FOIL the denominator, and we get 1 minus 2i plus I squared. We can keep simplifying because we have the I squared. So we have 1 minus 2i minus 1. Notice that the 1 and the minus 1 are going to cancel each other out. So we have 1 plus I over negative 2i. Now here we don't have a binomial in order to rewrite a conjugate. So remember what our goal is. Our goal is to get rid of the I in the denominator. And the way you do that is by creating an I squared. Since we have one I, we can multiply by I over I, which is just 1. And that denominator will become negative 2I squared, and then the I squared simplifies away. So let's multiply. For the numerator, we have I times 1 plus I. And the denominator, we have negative 2i times I. The numerator is I plus I squared. And the denominator is negative 2i squared. Let's replace both of those I squareds with their negative 1s. And the numerator, let's shift the position of the negative 1 and the positive I. The denominator, we can simplify. Negative 2 times negative 1 is a positive 2. We're simplified. Now we just need to rewrite this in a+bi format. So we have negative 1 over 2 plus, well, there's an imaginary 1 in front of that I, so 1 over 2 times I. Complex numbers are a little bit tricky, but with some practice they get easier. And of course, if you have a question or there's a specific problem you're stuck on, reach out to me and I'm happy to make a video for you.